Exploring black holes. Can we enter the event horizon? Black holes are among the most mysterious and awe-inspiring objects in the universe. These cosmic entities are so powerful that they warp space and time itself, creating regions from which nothing, not even light, can escape. The boundary of this region is called the event horizon, the point of no return for anything that ventures too close. But what exactly happens if we try to cross this threshold? Could we ever survive entering a black hole's event horizon? Or is it a one-way ticket to oblivion? Let's dive into the shadowy depths of black holes, peeling back the layers of physics and exploring what might await anyone brave or foolish enough to approach the event horizon. The nature of black holes, a gravitational abyss. To understand black holes, we need to first grasp the incredible force that drives them, gravity. Gravity is the force that holds planets in orbit, keeps the moon bound to the Earth, and causes objects to fall when dropped. But in a black hole, gravity takes on an almost incomprehensible intensity. A black hole forms when a massive star exhausts its nuclear fuel and can no longer resist the inward pull of its own gravity. The star collapses, compressing its mass into a point of infinite density known as a singularity. Surrounding this singularity is the event horizon, the boundary beyond which nothing can escape. The gravity here is so extreme that not even light, the fastest thing in the universe, can escape its pull. Once you cross the event horizon, you are forever trapped inside the black hole. This raises a terrifying question. What would happen if we tried to approach or even cross this cosmic boundary? Approaching the event horizon, spaghettification and time dilation. As you begin to approach the event horizon of a black hole, you would experience bizarre and unsettling effects. The closer you get to the black hole, the stronger the gravitational force becomes. But this force is not uniform. The gravity at your feet would be much stronger than the gravity at your head if you're falling feet first. This difference in gravitational force would stretch your body out, a process known as spaghettification. You would be elongated, pulled into a thin, noodle-like shape as you are torn apart atom by atom. If spaghettification weren't unsettling enough, you would also witness strange effects on time. According to Einstein's theory of general relativity, time and space are intertwined in what's called spacetime. Black holes warp spacetime so severely that time slows down as you approach the event horizon. To an outside observer, you would appear to slow to a halt, frozen in time, as you hover just above the event horizon. Meanwhile, from your own perspective, time would continue to flow normally, even as you are stretched and torn apart. Crossing the event horizon marks the point of no return. But what lies beyond? Entering the event horizon, the descent into darkness. Once you cross the event horizon, you enter a realm where the laws of physics as we know them begin to break down. The event horizon is not a physical surface, but a boundary in space-time. Beyond it, the black hole's gravity is so strong that all paths lead inward, toward the singularity. Inside the event horizon, nothing can move fast enough to escape the black hole's gravitational pull, not even light. All possible directions point toward the singularity. At this point, reality becomes stranger than anything we could imagine. Space and time become so distorted that you cannot avoid the singularity. The crushing force of gravity pulls everything inward. However, the journey to the singularity is a one-way trip. As you fall deeper into the black hole, the warping of space-time intensifies. Distances and time intervals become increasingly compressed, and the distinction between past, present, and future begins to blur. Inside this region, space and time swap roles. You are no longer free to move through space, but you are still being pulled inexorably forward in time toward the singularity. The singularity, the ultimate unknown. The singularity lies at the heart of every black hole. This is where the black hole's mass has been crushed into an infinitely dense point. Here, space-time curves infinitely, and the laws of physics cease to function as we know them. Gravity becomes infinite, and the very fabric of the universe is torn apart. The singularity represents the ultimate unknown. No current theory of physics can fully describe what happens at this point. General relativity, which governs the behavior of massive objects and gravity, breaks down at the singularity. Quantum mechanics, which describes the behavior of particles on the smallest scales, also cannot explain what happens. To reconcile these two theories, scientists seek a theory of everything, a unified theory that could explain the behavior of space-time under such extreme conditions. Could anything survive reaching the singularity? The short answer is no. The gravitational forces would rip apart any object long before it reached the singularity. Even atoms themselves would be stretched and crushed. For all practical purposes, the singularity is a point of total destruction. Could we ever explore a black hole? Given the extreme and deadly conditions inside a black hole, it may seem impossible that we could ever explore one. But some physicists have speculated about theoretical ways to survive, or at least gather information, about black holes without being destroyed. One possibility comes from the idea of wormholes. Some solutions to Einstein's equations of general relativity suggest that black holes might be connected to other regions of spacetime through a wormhole, a tunnel through spacetime that could theoretically allow travel to another universe or distant part of our own universe. If a black hole contained a stable wormhole, it might be possible to enter the event horizon and pass through the wormhole to emerge somewhere else. However, wormholes are purely theoretical at this point, and no evidence suggests that they actually exist. Another idea is that information about the interior of a black hole might be encoded in the event horizon itself. This is related to the holographic principle, a theory suggesting that all of the information about a three-dimensional region of space can be encoded on a two-dimensional surface. In this case, the event horizon would contain all the information about what lies inside the black hole. If we could find a way to decode this information, we might be able to understand what happens inside a black hole without ever crossing the event horizon. Could there be a future where we enter black holes? Although the idea of physically entering a black hole seems impossible with our current understanding of physics, it hasn't stopped scientists and science fiction writers from speculating about the possibility of black hole travel in the distant future. In some speculative theories, advanced civilizations might find a way to harness the extreme energies of black holes. Kardashev Type 3 civilizations, those capable of using the entire energy output of a galaxy, might find ways to manipulate black holes for interstellar travel, or even as portals to other universes. Could a future humanity find a way to safely traverse the event horizon of a black hole and unlock the secrets of the universe hidden inside? For now, that remains the realm of imagination. The dark mystery of the event horizon. Black holes represent one of the greatest mysteries in the universe. Their event horizons mark the edge of the unknown, a boundary where the familiar laws of physics break down. While it's unlikely that anything could survive crossing the event horizon and reaching the singularity, the exploration of black holes remains a tantalizing goal for future generations of scientists. For now, black holes remain shrouded in darkness, both literally and figuratively. They challenge our understanding of the cosmos and push the limits of what we can know about the universe. But in that darkness lies the potential for discovery. If we can ever find a way to unlock the secrets that black holes keep hidden beyond the event horizon.